Okay, hello, welcome to the Wrocław Jack. I'm really glad that you all came here. Today our guest will be Jędrzej Biedrzycki. I'm happy that you are here today with us. Thank you for coming. Everyone who watched this stream on the YouTube have a chance to win IntelliJ license. You just need to be active on the YouTube chat. During the presentation, you can just ask questions, and I will ask those during the presentation. I will just ask them during the stream. And I hope you will enjoy. Jędrzej, stage is yours.
Thank you, Sebastian, for this introduction. Thank you, everyone, for coming to my presentation. First off, I'd like to say that since the first day I have attended Wrocław Jack, I wanted to present there. And now I'm very happy and thrilled that the dream is fulfilling. I just only wish we could have met in person, but I think there will be an opportunity at some point. And today I would like to speak a bit about JPA and SQL. And to be more precise, I would like to go through my personal top 7 list of mistakes, performance critical mistakes that we can encounter when we're working with JPA and SQL. Of course, these both are specifications, and I will be talking about the concrete implementations. And for the SQL, this will be Postgres, and for JPA, this will be Hibernate, since those are, of course, the most popular vendors. And a few words about me. My name is Jędrzej Biedrzycki. I'm a software developer at Iteratec. My main responsibility is to develop backend of a web application. I'm also a PhD candidate at Wrocław University of Science and Technology, and my major is machine learning. If you would like to contact me, I have shared my email. A few weeks ago, I have also started my own blog. So if you are eager to learn a bit more about things that I find interesting in backend development, in everything that involves Java, Scala, and SQL, then please feel free to follow. And today I would like to present you 7 loosely coupled examples, loosely coupled mistakes that we can encounter. But to make it more significant, I would like to have a specific scenario. So let us suppose that we are building an application, a web application for a bookstore. For that, we are going to need a basic data model. So here we have 2 entities, a book entity with a title and a review entity with grade and some commentary. Those entities are related with one-to-many relationship. And you can also see that both entities extend abstract entity. I didn't show it here, but it's a class that contains only a long field named ID, which is annotated with ID, so that all the requirements for the entity are fulfilled. Then we are going to need a word class that is an embeddable. It has a name, some details, and the year it was awarded. And award is used in a book entity as an element collection. Suppose that our application supports messaging, and a message can have a title and the content, and of course an ID of the sender and the receiver, and a flag whether the message was read or not. This is also an entity. At some point, we are going to need a table of users. I'm showing you a table and not an entity because I will use this example in the SQL part of the presentation. And users table has an ID, an email, users row has an ID, an email, date of birth, and flag whether the user is premium or not. I'm creating an index on every column on this table, and then I'm populating it with the data, randomly generated. I will not go into details about this query that populates my table with data. If you want to know more, you can ask me somewhere in the presentation or after the presentation, but I have shown you underneath a sample result that we get. We can see that email is just a random string which ends with @gmail.com. Then we have date of birth, which is just a sequence of dates, day by day, starting with the 1st January 1960. And then we have an is premium flag, which is set to true with the probability of 1%. That's right here. And the last table that we are going to use is a table of incomes, which has a timestamp column when the income was registered. It is populated in a similar way as the column with timestamp before, but right now the difference between consecutive rows is 1 hour and not 1 day. And we have also income value, which is just a random value between 0 and 100. That's the model that we are going to use, and let's jump right in. The first problem that I would like to speak about is 1+select problem. Suppose that we want to display all the reviews from some books. We are given a list of IDs of those books, and we would like to display all the reviews that those books have on them. We can use the following methods. In the first method, we are fetching all the books by their IDs from the book repository. Then for every book, we are getting the reviews, we are flattening the structure, and then all those reviews we are passing to the display method. And how the display method is implemented is not important. What matters is that the method consumes review class, an object of the type review, to be precise. Now we are starting our application or running the tests, and we can see the following exception. Lazy initialization exception, which is probably one of the most commonly encountered exceptions when working with JPA. But why does that happen? To understand this, we need to go back to our mapping. You can see those two entities here, and we should remember that in JPA, the standard is that every too many mappings, so one to many, many to many, is fetched lazily from the database. And every to one mapping, many to one and one to one, is fetched eagerly. What does it mean? It means that every to one mapping is populated with the data from the database when the entity is fetched. But when we fetch something that is mapped with to-one relationship, then we are not getting the data there, but rather a proxy over this field. So if we fetch the book class or an instance of the class book, then instead of this list populated with data, we are getting a proxy. And that's what is happening here. Here we have all the books from our repository that we want, and then we try to iterate over the reviews, but the reviews is this field reviews is not yet instantiated. Hibernate tries to do that, tries to fetch them from the database, but the transaction is already closed. It was closed when we have left this find all by ID method. Since it cannot populate it with the data, it throws lazy initialization exception. So the question is, how can we solve this problem? If we dabble a little bit in the internet, for example, on Stack Overflow, we can find somewhere a couple of answers that state, just annotate this method with transactional, and it will work. Well, yes, but actually no, because the exception is gone, that's true. But the real problem is hidden. We cannot see what happens underneath, and that's what the real problem is. Let us now see what the Hibernate does under the hood. We can do this by specifying this parameter in application properties or in application YAML when we are using Spring for our application. And if not, if we are using sheer SQL, then we just need to add this property in the Hibernate config XML file, if I remember it correctly. And then we can see the log from Hibernate, all the queries that Hibernate generates. And we can see that we are fetching reviews, which is pretty intuitive. I have told you that Hibernate needs to instantiate or populate this lazily generated proxy with data, and that's what he does in the first line here. So when we access the reviews and the stream is of course consumed, then the Hibernate fires to the database, give me the reviews. But then Hibernate does something odd, because it generates many equally looking queries to fetch the book. Why does that happen? Once again, we need to remember that to1 is fetched eagerly. So now if we try to instantiate the list of reviews, for each child, book has to be populated with the data from the database. And that's what is happening here. And hence the name of the problem, n+1 select problem, because we have one select to fetch all the children, and then for each child, if there are n of them, we are firing a query to instantiate all the fields that are eagerly fetched. So we see that transactional is not the way to go here. What can we do? Other solution that we can find is one more thing that I would like to add is that transactional, just like everything else, need to be used, or should be rather used, the way it was designed to be used. So if we want to do something in a transactional context, if we would like to do some work that should be atomic, if something goes wrong, we need to roll it back, and so on. And another solution that we might find is to add this property in our mapping. So change the strategy to eager fetching. Okay, it will work in this particular example, but let us consider the following scenario. What if we had the following hierarchy in our data model, and we would like to fetch a single instance of the type A? What would then happen? Because we are fetching eagerly all the collections, then together with this single instance of type A, we are fetching together with this all the entities that are related to A of type B and of type C. And what is more, it cascades further, so that for each child of type C, we are fetching the entire collection of type D and of type E. So the only thing that we wanted was to fetch a single row from the database that was mapped to the type A, but we end up getting half of the database into the memory of our application. So that is clearly not the way to go. Another solution would be simply to tell Hibernate explicitly, what do we want, what do we need? And we can do this by using, for example, JPQL. That's what I did here. Here I'm selecting all the books that I want, all the books actually. I have omitted the where clause here, but it doesn't matter in our considerations. I'm fetching all the books together with the reviews. By using the keyword fetch, I'm telling Hibernate to instantiate the collection of reviews for each book that I'm fetching. And now we can see that Hibernate fires only a single query to the database. And that's much better because it's a single query, right? We can see that together with the book, reviews are fetched by using outer join. There are also other strategies, for example, nested selects and so on. If you'd like to know more, I have linked documentation underneath. But I would like you to think about one thing. What would you do for this task? What would you do to fetch the data to display all the reviews. If I were to write a sheer SQL query only in SQL, then I would use a select only on review table, because that's where all the information that I need resides. I'm not displaying books, and book ID is already in the review table. So why the hell do we need to fetch these books here if we only need to select reviews, right? So it turns out that the optimal solution would be to fetch everything lazily. So all possible relationships annotated with lazy fetching strategy, and then at runtime declaring what do we exactly need. And that's what I'm doing here by using native query. And we can see that Hibernate fetches only reviews. And notice one thing. This is the first time since I have started talking about JPA that Hibernate fetches the right amount of data for the job. This is the first time. So we need to have in mind how much is happening under the hood when we use JPA. Of course, we can use for this job also JPQL if we like to write queries that can be checked at compile time. We can use criteria query if we like to do it programmatically. We can use entity graph if we like declarative way. So how do you do it is just a matter of perspective of what one needs and likes. And one may wonder, is it okay to overwrite the JPA standard? I mean, in JPA, it's stated that all too many relationships should be fetched lazily, and all too one relationships should be fetched eagerly. So that comes from somewhere. That's right, but if we now take a look at Hibernate's documentation, we can find the recommendation there to make it all lazy, and then at runtime declare what we really want to fetch from the database. And this is the best way to take away the overhead from the database. Are there any questions regarding this example?
No, there is no questions about those topics.
Okay, thank you. We can go further to another problem, and that's manipulating an element collection of embeddables. Suppose now that we have a book that has some awards, and we would like to remove the awards by their names. And this method does exactly that. Let us see what happens here. We are fetching a book, having in mind what we have already talked about. So we are fetching the book together with the awards by the book ID. And then we are getting the awards from the book. We are filtering them by the predicate. We're packing them into a collection, setting this collection on the book, and saving the book with the repository. Everything is fine, and everything is saved to the database. But if we now take a look at what Hibernate does, we can see this. The first line is quite obvious and intuitive, because that's exactly what we have written. We are selecting a book together with the awards. But then I would expect Hibernate to remove all the instances or all the entities that I have removed from the collection, right? But that's not the case here. Here, the table award is cleared from all the rows that are associated with our book. So everything that has this book ID is wiped out. And then we are getting inserts, one insert per each object that is left in our collection. And why does that happen? Once again, let's look at this mapping. And we can see that award, I have already told you an award is an embeddable, but what does it mean? we can see that a word doesn't extend abstract entity. It doesn't have an ID field. So for Hibernate, a word doesn't have an identity, or in other words, it cannot be differentiated. So one instance cannot be differentiated from the other by Hibernate. Hibernate has no idea which objects have been removed from this list. It only knows what is left. And it uses this information as well as he can. So he clears the table and inserts everything that we have remaining in our collection. That's what's happening here. How do we solve this? The solution is pretty easy. Just write a query that does that. Here I have written a native query where I'm deleting all the awards by book ID and this predicate. And we can see that Hibernate fires only a single query to the database. But what if one says, okay, but I don't like SQL. I don't want to write native queries. I would like Hibernate to do this for me. Sure, no problem. Just exchange embeddable with entity and element collection with one-to-many mapping. The best solution would be to use bidirectional one-to-many mapping, the way we have talked about it in the previous example. And the overhead of this change is negligible. But if we manipulate the collection of embeddables, then we will see the difference. Manipulate it in this way that not only we're removing the instances, but we're adding new instances, we're changing them, and so on. So to recap, remember that embeddable do not have the identity when it comes to Hibernate. They cannot be differentiated one from another. So if we would like to manipulate the collections of embeddables, we should rather go for entities and the proper mapping, or write native queries, which works in all cases. Maybe any questions?
There is no question, but there is a comment from Camille. I believe n+1 can be hidden by Spring, even without transactional, due to default open session in view settings in boot when using REST.
Yes, that's right. But of course, that's true. It can be hidden by this property, but this property is considered very harmful and it's disabled by default, and it's not recommended at all to use it. So I didn't talk about this. But right, thank you for this commentary.
Yes, there is another one. What about non-international eager fetching? Hibernate will not lose lazy loading when field is optional, right?
When the type is optional.
Hibernate will not use lazy loading when field is optional.
Okay. Yes, maybe. I have no idea because I didn't use optionals as types, optionals of anything when using Hibernate, but yeah, that might be true. I know that there were some problems with optionals when Java 8 came out with Hibernate, so this might be an issue here. Okay, when that's everything, then we can move on to another mistake that we can encounter, and it's using Flash on EntityManager within the transactional context. Suppose now that we have written a review on a book and we would like to change the grade. We can use the following method for that. Here we are fetching the review by the ID, and then if it exists, then we can update the grade with the new one and save it in the repository. Now, can you tell me what is wrong with this code? Actually, there is no major error here, but rather a code smell, because this snippet is an equivalent of this one. The difference between those two is that in the latter, there is no save invoked on repository with the review, with the change field. But it still works. It still updates the attribute that we want to update. So why does that happen? And it works because the method is transactional. To understand it deeper, we need to fall back to the documentation, either of JPA or Hibernate, and we can find the following diagram there. When it comes to Hibernate and transactional work, then within a transaction, every entity is in one of the 4 states that are listed here on the left side. If an entity is fetched from the database, then it is in the managed state. If we create a new one, it's new. If we persist it, then it's managed. We can, of course, remove the entity from the database, and then the state changes to removed. And we can detach an entity from EntityManager. Then Hibernate doesn't control this entity anymore, and the state changes to detached. Now, if the transaction is closed, before that happens, Hibernate does 2 things. The first one is that it checks how did the state change for every entity, and if it did, then all these changes are translated into SQL and then fired to the database. For example, if we have removed our entity within a transaction, it's not removed instantly, but rather the state is changed from managed to removed, and upon closing the transaction, the delete statement is generated by Hibernate. And what's the second thing? If we have a managed entity inside a transaction, and there are any changes on this entity, for example, a single attribute was changed, then Hibernate records that there were changes on this entity. And upon transaction, if we have closing of the transaction, if we have an entity in the managed state, and there are some changes hanging on this entity, then an update or an insert, if it's a new entity, is created for this entity to reflect all the changes in the database. Now, I have told you that all this happens when the transaction is closed, but that's only partially true, because we can obviously see 2 arrows that point to the database from managed and removed state, and both are described with the flash method. It means that if we invoke flash on EntityManager during transaction, then all the changes are instantly flashed to the database. The transaction is not ended, but rather all the changes are saved to the database, and we can move on with our transaction. One more interesting fact to note is that I have told you that if anything changes on the entity, an update is fired. It turns out that Hibernate by default updates all the fields. When it comes to insert, it's the same way. If for some reason our entity has 100 attributes and we don't want the update to last forever, then we might be interested in the annotations dynamic insert and dynamic update. But that's just a hint, and we will not go into detail. But let us see how all this is reflected in a real example. Suppose that we have the following use case. We would like to display all the messages for a user and then set those messages as read. We can use the following method. It's a transactional method. Here we are fetching all the messages for the user by the ID, and then for each message we are displaying it, then setting the flag read to true, and then we are saving the message in the repository. Just to make a statement, here I'm using save and flash so that we can see what happens. And what happens is this. Exactly what I have described. We are going with our loop, and the first thing that we do is displaying the message. That's what's here. Then we are setting the flag to true and save it in the database. And that's the update that happens next. Then we are doing this loop again. We are displaying the message and doing an update, and so on and so on. Now, if we remove this end flash, or even what would be better, the entire line, because it's useless here, then we will see the following queries generated by Hibernate. We are going with our loop. When we enter that function, we are going through our loop one iteration by one, and we are displaying our messages. And when we go out of this method, then we are closing the transaction, so all the changes need to be reflected in the database. So that happens at the end. And you may wonder, okay, but in both cases, there are two updates issued in the database. So what's the difference? There's the same amount of queries that are sent to the database. Yes, but the difference here is when are they sent to the database. And the magic here is the batching that Hibernate uses. What we have here is this. We are displaying a message and then saving the changes in the database. Of course, the update is synchronous, so we are waiting for the database to process the data, and then we are going with our loop again, and so on and so on. And it lasts. And here we are doing our business logic, and then Hibernate generates all the queries, packs them into a batch or a couple of batches, and sends them to the database. And we, of course, know that doing this in batches will be much more efficient than doing this one by one. And Hibernate does that under the hood. We might not even be aware of this. That's how it is by default, at least. So what I would like you to remember from this example is that invoking Flash on EntityManager within a transactional context in most cases is a code smell and will probably cause some performance issues. I'm not, outside of the transaction, it will cause a runtime error. It will be transaction required exceptions, so I'm not discussing this case. Are there maybe any questions regarding this topic?
Are some questions. First of all, Marcin, congrats for dirty checking. Yes, you were right when you asked when Jędrzej asked the questions. What was wrong? He said that save is not needed. So congrats. About optional fields, he just tell more details about his question that by the way, I didn't mean optionals but optional relationship. If the association is optional, Hibernate has no way of knowing if an entry exists for a given table without issuing a query. That was he mean in last questions.
Okay.
And then we have some question about transactions. Going back to the last figure, so before closing transaction, each change is flushed into DB. What about rollback situations? Let's say that some attributes were flushed to DB and then transaction rollback.
Of course, flushing to the database doesn't mean committing the changes in the database. I have already said that if we lose flush within the transaction, then the changes are saved in the database, but they are not yet committed. I have told you that we are going on with the transaction, and it means that if something goes wrong, and if we have an exception that we cannot recover from, then all the changes, also these that were saved in the database by using Flash, are rolled back. So first, we are generating or Hibernate generates the queries. They are then run on the database, and if everything goes well, everything is okay, then the changes are committed. I hope that answers your question. Okay, I think there are no more questions, so we can move on with the topic. And the last issue that I would like to discuss regarding JPA before we move on to SQL will be relationship synchronization. Let us consider the following case. We would like to write a review for the book, and we can write it in several ways. For example, using Hibernate, we can build a review by populating it with the fields that we are passing in the method. We'll remember that review has a field book that is of type book, so we need to fetch the book from the database by using find, and then we can persist it. If we are using Spring Data JPA, then we can write similar code. We are fetching book when it exists, then we can populate review with the data just as we did before, and by placing this book in the book field, and then we are saving it in the repository. Now, those queries are equivalent. So in both cases, we can see the following output from Hibernate. And we can see that we are fetching book in the first query, which is quite obvious. That's what we did here with find method and here with find by ID, and then insert. But now let us, or I would like you to consider what would you do if you were using sheer SQL for this purpose. Suppose that ID is generated automatically. We need to insert book ID, grade, and review comment. And all these parameters are passed into the function. And all these parameters are in review table. I wouldn't write any extra select query for the book. The first query is just because we have a field type book on the review that we need to populate so that the relationship between book and this review is saved in the database. But actually, in reality, the first select is not needed at all. We are doing twice as much as we need on the database. But Hibernate has its own way to deal with this, and it's getReference method. If we now change this find method into getReference method, because the signature is the same except for the method name, then EntityManager creates a proxy over the book class that holds the ID. Or in other words, here we are not fetching the book from the database because it's not needed. We are only generating a wrapper over the book class, so it is visible to us as an instance of book that only holds this book ID field, so that the relationship between book and review are reflected in the database. And now we can see that Hibernate issues only single insert instead of two queries. Of course, Spring Data JPA is a wrapper over Hibernate, and it has its own ways to do this. And that's get one method from JPA repository, or something that is higher, maybe CRUD repository, but I'm not sure. I don't remember this. But there are ways to do that. And to summarize, I would like you to remember that using find in any way, so from EntityManager or by using find by something from repository, should be used if we need to fetch data from the database. And if we would like to only synchronize the references between entities, then getReference is what you want to use. Any questions?
Yes, there is one question from Piotr. What about solving n+1 problem with batch annotations?
Well, that regards the previous example. Yes, batch can help, but yes, this is going to help us if we are using, so let me go back with my slides to this example. I have told you that this is not the way to do this, and I have not discussed batch annotation. If we had batch annotation and used transactional, then yes, Hibernate would issue another queries to the database to fetch the data, but it would batch it. So it would be better, but it wouldn't be the best. So this is more of a workaround than a real solution to the problem. I hope that answers your question.
There is one more question. And what about handling cases when a book with given ID does not exist? Using getReference would require exception-driven approach to handle such case.
Yes, it's well, but it's not related to Hibernate really. If we allow user to or any other method to pass a non-existing ID, then there's not much to be done here, right? If we use find, we would get an exception as well as we would if we try to save an entity with proxy generated by getReference. So yes, we would have to handle this possible exception in some way. But yes, that's right, that it will be thrown a bit later by when saving this reference. But still, that is no problem, right? Because it won't be, nothing is saved to the database, so we are issuing only a single query in both cases, actually, because if this entity doesn't exist, then if we invoke find with non-existing ID or ID of non-existing row, then at this point should an exception be thrown. Okay, I think there are no more questions. And we can move on to SQL. And we can talk about indexes. And more specific, why aren't they used? Suppose that I have defined an index and the database doesn't use it. What could be the problem here? There are many possible answers to that question, but I would like to focus on a couple of them. And the first would be that there's a mismatch between the query and an index. We are writing a query in a way that makes it unable for the database to use the index. But let's go to the example. Suppose that we want to fetch all the users that are adults. And we can do this with this simple query where the predicate is that current timestamp or the interval between current timestamp and date of birth should be greater than 18 years. And it's all right, it works. And we all know that if the database gets the query from us, it doesn't go straight to the heap to dig out the data that we need, but instead it parses the query, creates an abstract syntax tree, and then for this tree, it tries to match an execution plan from many possibilities, or in other words, a way to get the data from the database, from the heap, that would be the optimal. So in other words, the fastest. And to get to know this plan, we can use an explain keyword. If we now run this query, we can see that sequential scan is used. A sequential scan, which means index is not used in this case. But why? We have created an index on date of birth in users table, and that's what we are using here. Right, we have created an index on date of birth, but here we do not have date of birth, but current timestamp minus date of birth. So it's some value that needs to be calculated first and then compared with something. And no calculations are done on indexed data. The index needs to be used as is. So how do we fix this? We can just flip around it a bit so that it's equivalent. But now on the left side of this operator, we have the indexed data, so date of birth itself. We now want all the users whose date of birth is earlier than current timestamp minus 18 years. That's the exact same thing as here when it comes to result, but when it comes to the execution plan, then we can see that index scan is used here. And that's what we wanted. Another example. Here we would like to fetch from the database all the users whose email has ABC substring in it, no matter the position of this substring. So we can write the following standard SQL syntax query with wildcards at the beginning and at the end of this substring, or using Postgres specific syntax like this. Those are equivalent, and the execution plans are pretty much the same. And both use sequential scan. But why? We are not doing any calculations on email. We are not passing it into the function. It's just an email on the left side of the operator, and index is not used here. To understand what's going on, we need to remember what stands behind an index. In every database, relational database that I know, the default data structure that is used for an index is a B tree. And if we remember from studies, what the B tree is it is a structure that leverages ordering to provide us with the lookup in logarithmic time. Right. Leverages ordering, that's the keyword here. And we can see that in our examples, ordering doesn't matter because we have the wildcard in our regular expression in front of this expression. So how can we solve this issue? How can we write the query so that the index is used? It's not that straightforward. If we can weaken the requirements a little bit, and for example, fetch all the users whose email starts with the letter A by using this query, then yes, index will be used because in this example, ordering does matter. And what if it's not the case? What if we need to have this wildcard at the beginning of our substring? Then we have a problem. But there are solutions to this, vendor-specific solutions to be precise, and Postgres has two data types, namely TS vector and TS query. That could help us with full text search. If that doesn't help, then what we have left is to have some GIN, right? I mean, generalized inverted index. If we cannot use B-tree because of the data structure that uses ordering, then maybe there is an implementation of index that uses something else, some other data structure. And the answer is, yes, there is. In Postgres, it's the GIN. It's a type of index that is more costly than the B-tree when it comes to maintenance. but the lookup, when it comes to full text search, is more efficient. So that's the trade-off. And it's up to us to decide whether we can live with longer updates and deletes and inserts, but instead have faster searches. In the next example, I'm going to take an Oracle database as an example. So I'm creating the table users in the same way as before, with an ID, email, and date of birth. And I'm creating an index on date of birth. And then with this query, I would like to check whether a user exists in this table whose date of birth is the 1st of January 1990. Oracle has its own specific syntax for fetching the plan. It's explain plan 4, and all this saves a plan to an inner table, and then we can retrieve this plan by using the following select query. And we can see the result underneath. Here we have that it uses full table access, which is an equivalent of the sequential scan is in Postgres. But we do have this index on our date of birth. We're not doing anything to this date of birth. We are not using any regular expressions or other wild stuff. Why doesn't it work? It's no coincidence that I have used Oracle here. There might be some of you that have had the pleasure to work with Oracle and know that Oracle treats nulls in quite an extraordinary way. For example, it doesn't index nulls. Here we would like to know whether a row exists with this value. If an index doesn't index null, then not all possible values are within the index. We cannot use an index to check for the existence of this value because index doesn't cover the entire range of possibilities, because there's this null that is not in the index. So how can you solve this? We can try to make it work by doing so that there is the same data in the index and in the table, in this column of the table, by, for example, getting rid of nulls. If we can do this, of course. If we now create the database, but this time with not null on date of birth, and run all those queries one more time, then we can see that the index scan is used in this example, only by using one more constraint in the table definition. And another possible answer to why index is not used is that we just ignore the statistics when we design the indexes. What do I mean by that? We have a simple case. We would like to fetch all the users who are premium, and this query does that. It's very simple, nothing to explain here. But if we take a look at the plan, that's also quite intuitive, and index scan is used because we have an index on each premium column. But what if we now flip the predicate? So what if we add not and try to run this query with explain? We can see that sequential scan is done in this example. And why is that? You might remember when I was talking about the data model that when we populate the table users with the data, we are setting isPremium flag to true with the probability of 1%, which means, and that it's proved by these queries, so to say, that if we now compare the amount of users that are premium to the size of an entire table, then we have approximately 1%. Only 1% of users are premium, right? So what would the database do if it were to use the index when executing this query? It would go to the index to find out that the first row contains false, and then it would go along the pointer to the heap to dig out all the columns, because that's what we need with this star here. And then it would return to the heap just to find out that another row also is false, to go to the heap, and so on and so on. Too many round trips. There's just too much work for the database, too many round trips between index and the heap to fetch the data. So in this example, just scanning the table is a better solution when it comes to performance than using an index. And the last possible answer to why isn't index used. In this example, I will use one more time Oracle database. And we are given a task to save a date in the database. But we would like to save it in a format where only year and month is stored. So only those two values are significant to us. And there are multiple possible solutions that we can use. We can simply use the date. And that's the first column here. The other solution would be to save it as varchar with 6 characters. Now the first 4 characters would be for the year, and the last 2 would be for the month. We can cast this varchar to the number, so it's the same value but with a different data type. And that's the third column. And the fourth column is very interesting because that's the amount of months that have passed since some date. As the reference date, I am using here the beginning of Unix. So January 1970. What does it mean with this column? If I would like to encode January 1971, I know that 12 months have passed since the January 1970, so it would contain the value 12. For the January 1972, it would be 24 months, so the value is 24, and so on and so on. Later on, I will talk about this column as number continuous so that it's faster, and I am creating indexes on each column of this table. I am populating it with the data. Once again, I will not go into details because this query generates some values randomly by using Oracle specific syntax. We can talk about that later if you wish. And then I'm gathering of the stats of this table. And the results, sample results, are as follows. If we have now, for example, March of the year 2043, then we can encode it as a string, 204303, as the number. So that's the same value, but with different data type. And this many months have passed since the January 1970. And now I would like to know what plan will be used if I were to fetch all the rows that fall between December 2016 and January 2017. I will give you a moment to get acquainted with those queries. And if we now take a look at the result, I hope it's visible, we will see that the first column and the last column, so date and number continuous, use the index, whereas the second and third don't. And why? That's the great question here. Why does that happen? Let us analyze those queries. In the first one, we want to fetch all the rows that fall into this range of 1 month. But we have seen that there are quite huge values generated here. For example, year 2227. So the range of 1 month is pretty narrow in comparison to the range of the values in this table. This query is very specific. So Oracle knows that it can use index to fetch this because there won't be many matches. If we now take a look at the last statement, we are only interested in 2 values, so it's even more obvious. We are only fetching the rows that have the value 564 and 565, and no others. These 2 queries are very specific, and the index is the perfect match when it comes to creating an execution plan. Now, if we take a look at the second query, here we want to fetch rows whose varchar falls between these 2 values. Now, if we take the first value and append anything to the end of it, be it a car, a number, a special character, it will fall between those 2 values, but we know that in reality, it's not possible, right? For example, a value 201612A will be a valid candidate for this query, but we know that it doesn't make any sense. And the same applies to the third query. We now have all the rows that fall between these 2 values. So the value 201,699 will be between those 2 values, but we all know that it doesn't make any sense because there are no 99 months in a year, right? So with this encoding, with the varchar and that number, we are fooling the database so that the queries that we are using here lose their specificity, right? Oracle thinks that these queries are not specific, that the range is way broader than it really is, and it decides to use the sequential scan to fetch the data. If you are interested in this problem, I can recommend you a more in-depth analysis in this article. It's very informative. And to summarize this, the whole topic of indexes, I don't want you to remember all these weird quirks with sequels that I have shown you, but rather I wanted to show you different problems that you may face when you are analyzing the performance of your queries and why index is or is not used, and ways to debug this. So if you face these problems, then explain is your best friend. Just take a look at the plan, how it looks like, and then try to figure out whether it's right. And if it isn't, then what can you do to fix it? Okay, that was a bit long. Are there any questions regarding this topic or any others?
Yes, there is one question.
Great.
Question: is it possible to force using index by Oracle query hints?
Yes, it's possible if the index contains all the data that is needed to do that. But I don't think of myself as Oracle expert, and so I don't know how this hint would look like. But I remember that we can force the strategy that is used. And if it's possible, then Oracle will take it into consideration. Okay. Let's move on to the next topic. It will be shorter, I promise. Here we would like to check whether something exists in our table. Suppose that we want to fetch all the books that have or do not have reviews. And we can do this in several ways in SQL. For example, we can fetch the books whose ID is in the table review under the book ID, or isn't, if we would like to invert this predicate. Now, an interesting fact is that if we use distinct in this nested select, then the execution plan will change slightly. Then we can use outer join. We can join book with review and then check whether the ID of review is null or isn't. If it is null, then there are no reviews on this book. And if it isn't, there is at least one review. A variation of this method is by using inner join that will filter out all the books that do not have any reviews. Another solution would be to simply count the occurrences of the book ID in the review and then select all the books that have this count equal to 0 or greater than 0. And the last solution would involve using exists keyword. So we are selecting books where there exists a review with this book ID or doesn't exist. Now I have run these queries on my machine, well, actually on Docker container, 10 times. I have averaged the results that I have obtained from using explain analyze, and the results are as follows for the table with 100,000 records. Here we can see that using in is pretty efficient because this query is optimized to the same as if we were using exists when we are fetching for the books that have reviews. But it's not the case if the book doesn't have any reviews. If we use distinct, then it's a bit better, but still it's way more time than if we used exist. If it comes to join and count, the situation it's a tragedy, so I will not go into details. But I would like you to remember that if you are checking for existence in SQL, then we have a special keyword for that. Are there any questions?
No.
Comments?
Yes,
Great.
there is a question. Is it possible to get slides?
Slides?
Yeah, from the presentation.
Yeah, of course, yes. I will share them at the end. Of course,
Yeah.
of course. I'm aware that this presentation is pretty packed with information, and I would like this to be sort of a reference for you to use in the future if you face the problems with performance in your data access layer. So of course, I will share both the slides and the project where everything is written when it comes to JPA and SQL. I will talk about that later. But now I would like to talk about the last problem, finally, which is not using window functions by developers, of course. Suppose that we have the following task. We were asked to calculate the income per month. It's pretty easy. We can truncate each date so that all the dates within a month fall into a single group, and then for each of those groups, we are summing the income value. That was pretty easy. But now things get a bit more complicated, and we were asked to calculate the difference between consecutive months. So what's the difference between income in January and in December the previous year, for example? I would like you to remember this query because we will use this further on. And we can solve the issue using this query. It may look complex, but it really isn't. I would like to first explain what it does and then go into the syntax. So if you are reading this, then please stop and listen to me how it's done in the first place. Here we have this view where each row contains a month and a value for each month. And then we are joining this view with itself, and it's shifted by 1 month. Then in each row, we have a value for current month and the previous month. So the only thing that we need to do is to subtract those values from each other. And that's exactly what this query does. We have this view here. It's named as current month, and we are joining it with itself with the name previous month. And the joining predicate is that the current month needs to be a month after the previous month, right? That's obvious, but that's what it does. That's the offset that I was talking about. Now in each row, we have the value for the current month and the previous month. And the only thing that we need to do is to calculate the difference between them. Now, if we run this query, it will take 416 milliseconds. And it might be hard to read, but we can refactor it if we know what a common table expression is, or in other words, with keyword. We can pull out from this query the view that we are using. That's what we are doing here. This select is the exact select that we have from the beginning of this example, and I am naming this view as month aggregate. And now this month aggregate I am using in every place that it was used before. So I am joining month aggregate named as current with month aggregate named as previous with the same predicate. So the current month needs to be the same as previous month plus 1 month. So it's pretty much the same, but refactored in the way that the view is pulled out. Now it's a bit more readable. But if we run this, then it runs even faster. It takes half of this time, 416 and 224. Why is it such a difference? It's because this with query materializes this view only once. So we are materializing this view once, and we are reusing it in those 2 places. Whereas here, Postgres doesn't know that those 2 views are the same thing, so it cannot optimize it. Here we are doing this work twice. But there is yet another way to solve this problem. I know it's late, but I would like you to think, how would you solve this problem if you were given a sheet of paper, like a spreadsheet with the income value per each month? How would you solve this on a sheet of paper? I would certainly do it in this way, that I would take a look at the first row and then at the second one, and I would subtract those 2 values from each other, and that would be my difference, right? Then I would move this window of 2 values so that now I'm considering the second month or previous month. And now I'm subtracting, for example, if now it's October, September and August, right? Values for September and August, and so on and so on. I'm subtracting values from consecutive rows. And we can do this in SQL. What we need to do is to first order the view by months, and then take 2 consecutive values and subtract them one from another. That's what happens here. We have, once again, the same view. We are ordering it by the date. So effectively, we are ordering it by month. And then we are subtracting from the current value, the value from the previous row. And the previous row having in mind this ordering is the row from the previous month, right? Now, if you are used to window functions, you would say that this query is the most readable because it's just intuitive. It's how we would use it if we were to calculate this. It simply states that we have these aggregations for each month, and we are ordering by month and then subtracting subsequent values, 1 month from the previous month, right? You can be more explicit about this. If we now take a look at this query or even this one, then we need to spend some time reading this first and then spend even more time trying to figure out what happens here, right? Why do we have two same views here? Why do we join this in the way we do that? Where does this offset come from? And so on. So you can improve this query when it comes to readability, but also when it comes to execution time, because this one, once again, takes half of the time of the previous one. Here we have 224, here we have 110, which is less than half of the time. And the lesson from this example that I would like to share with you is that window functions can help you refactor or write queries in a way that would be more readable, but also it can be even more performant than some standard ways by using nested joins or nested selects and joins and so on. But it's not always the case with the performance. If the query is performance critical, then don't take my word for it. Just write the queries and test them, right? Then check out the execution plan, check out the execution time, and pick the solution that best matches your needs. This should be the lesson from the entire presentation, right? If you, however, decide to stick to the solution with nested selects, joins, and so on, then please remember that this common table expression or the with keyword can help you refactor it so that it's more readable, and you can also win when it comes to performance. Sometimes it's even better. And that's everything that I wanted to share with you. As I have already mentioned, the slides will be hosted on Slides. Yeah, that's the name of the site. And also I have created a project that's a simple project in Spring Boot, where there are all the mappings that I have discussed so far with the tests. So you can check out what happens there. You can play around a bit. You can check if I have lied here when it comes to values and outcome, you know. And thank you for your attention. Oh, and before I hang up, I want to mention the bibliography. I know no one reads that, but maybe you can make an exception here, because I have tried to make it comprehensive. Those are the positions I have used to prepare this presentation when it comes to Hibernate. I have also shared some interesting facts regarding Hibernate, and if you would like to know more about the performance in Hibernate or deepen your knowledge about JPA itself, then those two positions are great reads. Then these positions I have used to prepare the SQL part. And if you would like to know more about the performance of SQL and so on, about the data access with relational databases, then I strongly recommend all those reads. They are great. For example, Marcus Winant's SQL Performance Explained, that treats about indexes only, or Martin Klepan, Data Intensive Applications. And those are great books, not only if you have problems with performance in your persistence layer, but just to understand the art of working with the data, to say that poetically. Thank you very much. Maybe there are some questions.
Okay, there is only one comment worth to mention that in SQL Server with clause cannot be put in a subquery.
Yes, in Postgres as well.
Yeah. So there is no additional questions. Nothing I see. Thank you, Jędrzej, for
the presentation.
For being here. That was amazing. That you made people ask a lot. So this is great. Thank you all for being here and asking and being such active in the comment section. So yeah, thank you. And I hope someday you will be in the Juk in the person. So you will have another maybe talk.
Yeah, I hope so. Maybe it will happen soon, maybe in person. I really hope so. Thank you very much.
Thank you. Goodbye.
Bye.